All right, we're recording.
Yeah, hello everyone. Hello, Kirk and Andrey.
Turn your volume up. Nick, your volume is too low. I can barely
Volume.
hear you.
Oh, that's great that you said it because I know it happens sometimes. Now it should be better. Hello,
Oh, much
everyone.
better.
Hello, Kirk. Hello, Andrey.
Hi.
Yeah, long time no see. Let's let's do random stuff as we usually do.
Yeah.
because a few weeks passed and our attention shifted to another place, but we do it for ourselves mostly, right? It's just fun to be live, and I know some people like to watch it, so let's do it. What's in your mind today, Andrey?
Kirk suggested an interesting idea that we have materialized views, and that's very cool feature. And you can refresh materialized views, but you cannot refresh it partially. Partial materialized views refresh is absolutely uncommittable, but we have extension of SQL. We have refresh materialized views concurrently. So we don't have to lock table from changes. And I have no idea how it works, but it works. And if we try to implement this feature that Kirk suggested, maybe I will understand how it works. So that's the main purpose of trying to implement this feature, like trying to build a mental model. Honestly, I do not know even like where to start, but we will come up with something.
So let me start by introducing the materialized view, right? And talk through an updatable one that we can refresh concurrently. So a materialized view, special syntax, create materialized view as a normal view syntax. If it has a primary key, then you can actually do something called refresh materialized
Unique
view
keys,
concurrently, right? If it has a unique key. A unique key, I apologize.
Just unique key.
Nope. So if it has a unique key, you can actually use the concurrently option when you refresh it, and that doesn't block everyone else who's using it. So this is really handy when you're joining, like in our case, we use it. We join about 12 tables, right, to make this complex view. But it summarizes a bunch of data to the individual level. And then we have about 4,000 rows. So the challenge is we're constantly updating one or two columns in there in real time that need to be, okay? So the problem is we have to refresh all 4,000 rows and every column, okay, concurrently all day long just to get these one or two columns per row that needs to be updated, okay, every few seconds max. So it creates a crime. So, but we can do it concurrently, and concurrently requires a unique ID. And then the next question is, oh, if we added the ability to say refresh this concurrently for ID 125, shouldn't it be able to just use the code that exists? And that's kind of where Andrey and I started talking. But so the materialized view is very useful this way. You know, it's fast, the refresh works, everything's great. But if you constantly have to regenerate it, it's a lot of work in our case. So we want to look at this, see if it's an option, okay, or how we can do it. Now, Nick, I'd like to bring you in. Why do you think it's absolutely uncommittable, even if we got it working right?
No. This is Andrei's words. I wanted to add that
Yeah.
the problem you just described. Yeah, the problem you just described that refresh materialized views, refresh materialized view concurrently always refreshes it fully. There's no way to refresh just a few rows. This is the primary reason why we, by default, recommend avoiding materialized views in Postgres to our clients who are big, who have a lot of data. And when they discover materialized views, like for me, materialized view is a way to have a single index-only scan, so the most efficient query plan, while we have data in multiple tables. So you cannot create index for multiple tables. You can create it through having materialized view. And then you have single index-only scan. But since you cannot have partial refresh, We can call it partial refresh, by the way. Why not?
Yeah.
Because this is incremental update, it's like too complex for my mind, actually. But I know this is a common term. So we usually people discover they are super happy until they are not happy, and it can have bloat. It can have bloat. So sometimes we need to deal with bloat there, and it's super inefficient to refresh it fully while we need only a few rows. And when project is small, it's fine, but when it's big, it's big. It's one of our clients said a long time ago that this reminds a huge hammer, which is used for a very small nail. Yeah, that's the
And
problem.
it's easy to fall in love with it during testing. And this is one of those many things that when you're just testing it, it's like, oh my God, this is great. And then when you realize, oh, we have to update this 250,000 times a day. Like, we're doing so much IO to compensate for this. It's crazy. It's not worth it, right? Or is it worth it? So, Andrey.
So what is committable and what is not committable? Like bringing something into the core database, it must be consistent. It must be standardized. It must be it should like promote best practices and not try to partition like not break data flows and all that stuff. But it's about committability to core. In Postgres, we have like committability to extension. This is like second class of
Yeah.
of functionality, but it's real. I can say that like first reason not to commit this stuff into core is because it's not a standard SQL. The second is because it promotes inconsistent practices about managing data. And the third one is my personal number one. Concurrent DDL and concurrent changes are actually error prone. I have fixed myself several bugs that were leading to data corruption. That's why it would be very difficult to find a reviewer and a committer for such a patch. But that's absolutely not a reason not to start, not to try.
Well, and then
So,
next up is there a chance that we could, if we get this working, that we could extract enough of it and put it in as an extension that modifies the view?
There is extension, right? Already there is such extension. It's called
Yeah, it does it by linking and creating triggers and going in the back
really?
end and trying to update the tables.
Did you IBM?
Yeah,
yeah, I
You
heard about it.
yeah.
Incrementally
So
maintainable
it incrementally
visualized
maintains
views.
it. Yeah. So,
okay.
and it's for our use case, it was overkill. And part of the problem is our base query is really complex and it touches so many tables.
Yeah.
And we didn't want when I read through what they offer and how it works, it attaches itself to every table on the view and then tracks changes to that table and then cause the code to call it to refresh was my understanding on this. So basically every time any table that's involves a change, insert delete, then it calls the code to kind of incrementally update this view. Okay.
Why I see. So it's fully automation. Why we don't consider just refresh materialized view concurrently where?
Yeah, exactly. That's what I'm talking about. Yeah,
Oh,
where
okay,
or for.
okay. I just
Yeah, yeah.
have
I added for is just an
So
alternative
where
syntax. When you use where, it gets weird to use
so
DDL.
we don't try to automate the logic of cache and validation. This is, by the way, one of the hardest problems of computer science,
Caching.
or one of two. Yeah, because materials view is cache,
Yeah.
and
yes.
logic for cache and validation can be very different. Depends on use case. But instead of trying to do that, we just try to do partial refresh.
Yeah, exactly.
That's it. Because we don't try
So
to solve a bad problem, hard problem. We try to solve problem that lacks right now, right?
And Andrey made this point. The current one for refreshing concurrently requires the unique ID, which means it probably understands enough that will actually help us. We're hoping that if we can provide a limited set of IDs, we get the proper response. That would be like hitting it out of the park on the first try. But Andrey, did you freeze? Oh, yeah, you did for a second.
Sorry, the connection interrupted a bit.
Yeah.
Do you hear me?
We hear you now.
I try to
maybe we should turn
raise
off
laptop a bit higher.
Maybe turn off your video. Let's like your voice. Also, we need screen sharing. So yeah.
There you
Yes,
go.
let's try to share my screen. Do you see it now?
Yeah. RMV.
So, yes, I created a copy just to be sure, and let's install it, and just a second. Let's create an empty cluster and maybe try a bit what we are going to work on. So we have a table. Select, I don't know, maybe random numbers.
At least create a couple columns. Yeah.
Column A, column B, from generate series 100.
As X.
And name X.
Yeah.
So we have a table star from X. Or there is a table X, same syntax. And we want to have a materialized view create, materialized view Y as.
Could we at least call it
select
MV underscore Y, just so it's obvious it's a material, right? Good. There you go.
Let's go.
Oh, there you go.
Yeah. Select A, count star. Count sum B from X.
You're going to need a group by.
Group by. By the way, have you heard that
Auto group by? Group by any? Your audio is cutting. I'm going to kill my video in case my video feed is slowing you down.
Yeah, I think
it works already.
Hold on. Okay.
Because it's the standard, and just go and get closer to huddle. Do you hear me?
Yes, you are breaking up, unfortunately.
Yeah, you were breaking up. He's going to reconnect.
Yeah, meanwhile, I'm checking the existing work or past work in this area. It points me to PGIVM extension once again, which is different. Okay. So looks like PGIVM is the most popular in this area, but I would.
Guys,
now we can hear you.
You're breaking up still.
Do you hear me? So I stopped at the point that now group by all is supported by the standard.
Yeah.
Oh, nice.
Did you notice it?
I didn't notice it was there already.
So in next version.
Oh, so version 19 will have it, or 20.
Yeah, it will be next version. So now we have materialized view. Select start from MV. It works, and we have refresh materialized view concurrently MV. But it says that we need a unique index.
Yeah, first.
Create index on XA. Like this should work.
Hold it.
Do you hear me?
Yeah, we hear you. I'm trying to figure out why the unique index doesn't work. Oh, you created a unique index with no where clause on one or more columns.
Uh-huh. I see.
Oh, hold on. No, you got to create the unique index. Hold on. Unique index not on the table, on the view. So you got to create it on MV. Up arrow again.
Okay, so
Up
we
arrow.
need
You created a table on X, so right.
Oops.
Now go to the
Create or replace materialized view.
Go to the
There is
create
no
index. Go to create index. Pull it up. Go. Stop. There you go. On MV of A. There
I
you go.
don't think. Oh, it works. Oh, I
Yeah,
didn't know it.
because it requires it. The materialized view itself
For
needs an index on it.
concurrently. For concurrently, it's needed. Yeah.
And by the way, this is what Nick mentioned in the preamble, that one of the nice things about materialized views is you can create only the indexes on it you want the optimizer to use. So you create the one
This is
beautiful
the
index.
main reason for me, because yeah, again, we cannot create index on two tables, but we want perfect plans. Perfect plan is a single index scan, or it's single index only scan. And materialized view is a bridge to that perfect plan. So if we read from two tables, we have filter on one, filter on two, like some order by, like sorting. And we want single index only scan. So our query is below 1 millisecond, for example. In this case, we do need materialized view. That's the reason.
My next plan is to ask Cursor to explain me how it works, because I don't know.
Yeah,
Okay.
look, while we were talking, I already did some research. I shared it in Telegram, and maybe you have you can use
I see it
some
in Telegram.
hints. Yeah.
Telegram, just a moment, I'll check it. It's about incremental view maintenance. That's another patch that is not committed actually.
It's different. I'm still talking, but it gives you insights like where the code is and so on. Yeah, with incremental true. Yeah. It's not commit. So is it in commit fest?
It was rejected a few times, but Yuba Nagata, the author, he's still working on it, and he's very focused guy. I think he will commit it to Postgres. I'd say like 22 or 23. So how to write a prompt? So we need a plan. This is Postgres code base. We are going to work on extending materialized
Oh, by the way,
views.
someone is asking where, like, actually, guys, do you want Discord or Telegram or Slack for asynchronous communication with others? What do you think?
Personally, I prefer Telegram because it's easier.
Okay.
And I would be happy to have some medium, some way to collaborate.
Yeah. I think we should create a group or something. I'm going to
in
do
Telegram
it right
for it. Yeah.
Good.
We can refresh, realize, confirm. which requires
A full table or full table refresh or full view refresh, but
full view. We want to be able to refresh each part and
using the IDs, I would also add. Refresh it partially using the unique key.
For
I sent something more on Telegram, but just in case, like distracting you.
Thanks.
Yeah.
Let me
This
scroll
is
through
about
it.
this is about where ideas how to implement where.
So you see in the core architecture where it does all these triggers, right? Trigger-based maintenance, and it captures this before and after in your post, Nick. I'm just talking to Nick while you type that. That was when we calculated that was kind of heavy for us. And most of the tables weren't being updated, which was good, but
we cannot use syntax where because this is part of the syntax for views already, right? So
right. So that's why I was thinking maybe we add the syntax for. So we refresh the materialized view, right? Whatever name concurrently, or concurrently whatever name, and then we add like for, okay, and then we use something that evaluates to a set of IDs, okay, or an expression ID greater than whatever, unless where could work. Go ahead.
I do not understand what's the problem with where here?
Oh, I don't know. Go ahead.
So
Nick.
Views and materialized views as well, they already support where syntax. This is inside
it's when you create materialized views.
Yes, but we want to specify the scope of
refresh it.
Yeah,
I think we're fine on the refresh syntax if we add where.
Okay.
Right, because it's different syntax.
Okay, so create materialized view where means one thing.
No, you don't say create materialized view where. You say create materialized view as select.
Where is a part of
the select statement.
Clause.
And then in our case, we're not going to create it with a where clause. We're only going to refresh it with a where clause. And that syntax doesn't include the select. Right? You just say refresh it.
Refresh where? Well, there's no contradiction here, right?
Yeah, there's no confusion.
Okay.
No, good attention, man.
I'm trying to send the query to cursor, but it's...
Oh, Azure is having problems right now. Some of our services have went down, and I can't reach the Azure portal. I let me double check.
Maybe try a different model, GPT-5. And is it cursor is being updated every day? Is it fresh version or not?
I just installed mine. Aha.
I'll just try to exit and start it again. It worked today.
Yeah, what version is it? What is your cursor version?
Um,
2.0 point something already.
So perhaps I can update
can you log in real time right now? Nick, I can't log into my cursor right now.
Okay, time to use Cloud Code in
Maybe
terminal. I actually like it a lot.
I don't know, maybe we can try to understand it by reading code.
Yeah, well, check out Telegram. I already used Cloud Code to brainstorm some things about.
Yeah, cursor appears to be down. I'm not able to log in on their cursor.com homepage. All right. Between
Their status page says all good.
That's wild. Go to cursor.com, Nick, and
Oh
try to
no,
log on.
there is service degradation. I was wrong. There is
Oh.
service degradation. Yeah, on statuscursor.com there is service degradation.
I'm reading Telegram from a phone.
Okay. Yeah.
Yeah. So there is a lot of text to understand, but I don't know
Yes.
what code to change.
Yeah, how about
maybe
first find the syntax for the refresh materialize view concurrently. And let's see if we can't maybe start there and then see what we can learn after that.
I'm thinking where to find this file.
Yeah, this is 1 second. I had it. So it's backend comments mat_uc. There is a refresh by. So yeah, so comments mat_uc. All the logic is there. Yeah.
Refresh by matching merge and refresh by heap swap. I suspect that heap swap is just like blocking refresh, and the other one, refresh by matching merge, is incremental date.
Also, I just realized this patch you mentioned, which is rejected. You said rejected a few times for incremental mat_view IVM. It's the same from the same developer who created PGIVM. So basically, the idea is let's bring it to core, right? Yugo Nagata. Yeah,
Yugo
that's
Nagata
great.
is working.
Yeah.
I just found out that I have a client bot. Maybe I will just copy this prompt and try to ask client.
I like Claude Code really. If you have Anthropic account, Claude AI account.
I don't have it.
You
right
don't like
now.
terminal. You don't like terminal, eh?
I can't say that I don't like terminal. I just didn't try actually Claude Code yet.
It's great. It's great. It doesn't have capabilities like Cursor, like browser, or ability to understand screenshots. This I like a lot in Cursor, but everything else it's really great.
Client is also not working right now.
So I sent some more data in Telegram. Check it out. It's not a lot of words. I'd ask to be short. And this is really like basically brainstorm how to support where and partial refresh. What do you think?
It suggests start from tweaking grammar, and tweaking grammar is actually easy. So we can start from there, and I'm sure that I can do it by hands. But the interesting part is data.
Yes.
And it's not about parsing query. And
Well, I agree. But maybe we should just do it differently and make sure that it's possible. Because like if we create grammar but then figure out it's not possible, it will be wasted effort, right?
yeah, maybe it will get back or not. So, okay, let me read further. Second step is grammar too. And third step is updating pass nodes. It's also about grammar. Or is about how we represent a plan. Okay, it's not about grammar, but it's about very very close to abstract syntax tree. And the fifth step is actually refresh materialized view. Let's see. Okay, let me scroll further. Okay, the final 6 steps says that the function refresh by matching merge, this is exactly where the code is right now, contains simply SQL queries. Maybe we can find the queries and understand what is going on. It looks like it's actually just executing some SQL queries. Hmm. So here we should find the index that we use. Guys, am I still online?
Yeah. All good. We hear you. We
Good.
see you.
Okay.
Screen sharing. All good. Yeah.
So this is the place where we create a difference table. There is. So here we going to delete something from our materialized view. This is some SQL magic here. How this is going to work? Operator from PG catalog, and this will invoke operator, and this select query is going to find all the data that needs to refresh, and then we are going to delete it by ctid. And basically we just want to add where here, like say and some extra where clause that we are getting from our grammar. And then we will insert new data. And drop temporary table of new data. It looks like that all the magic is just SQL queries, but I do not understand most of them. It would be interesting to simply be able to print these queries to see what is going under the hood.
Yeah.
All these queries go through SPI. As far as you can see, they all go through SPI exec. Let's add login to SPI exec.
It can be, okay, let's do it. It will be logging a lot of more things, right?
Probably so, but I don't have a better idea.
Maybe there is already a way to log all.
Maybe there is some login.
Maybe just debug level 5, debug 5. If you just raise log messages to debug 5 should be logged. I'm checking quickly. Is it debug 5 or debug 1, which is more verbose?
You can just try to set it.
Yeah.
Here. Set min
client min messages. Client min messages.
Client min messages
to debug 5.
Debug. Let's start
debug 5. Debug 5. I think debug is just debug 1. If you do debug 5.
Yeah. I thought that
okay.
Start with something.
Yeah. Okay.
And then add levels. But let's go with debug 5. It looks like it was a very similar number of.
No. Yeah.
So there is no logs for queries executed with SPI. So let's proceed with adding this login SPI exec percent src and make install. GCTL test PSQL. Boom. I've broken accidentally. Let's get it back and fix materialized views. Where is my change? Where is it? Where is it? Is it? Okay. We start with analyzing some temporary table because probably it was some
Sorry
difference.
about that, gentlemen.
Hi.
All right.
So, Kirk, we tried to we added some login of what refresh materialized you concurrently is doing under the hood, and basically it is just doing SQL and nothing else.
Oh, so what it's doing is it's going out, probably creating a temp table, loading all that data in a temp table, and then it's generating a single set of delete and inserts for everything. And then it deletes and inserts everything from the temp table.
So probably
And then when it commits that, it counts on the transaction ID and the eventual auto vacuum to clean it all up. Interesting.
yeah. Have you ever saw something like this before? Saw something like this before? What is it?
Yes. Yes. Okay. Because there are some object type special features, you can override what some of the operators do. Okay. In different classes, like whatever, for like different index types, the operators mean different things. And so there is the ability to change some of that. So what this is saying is the operator, okay, my understanding is that this says use the PG catalog's definition of equals for what I'm doing. Okay, so this is
And
comparing.
it compares many columns at once. Everything in relation new data and everything in relation MV.
Yeah, isn't that cool? I've never seen that operator. Does it work in real syntax, or is it like only internal syntax?
I don't know. Let's try to execute it.
Yeah, we can. Andrey, I love how you are. Let's not try the delete though. Control X, Control E will put you in the editor mode. So you can be inside of either VI or Nano, then you can edit it down inside. Control X, Control E right here. And that'll usually open up an editor. Control X and then Control E.
Control X, Control E. It
Yeah.
doesn't work.
Okay,
Maybe
just do.
Command X.
No, just do \E then. Yeah, I forgot that was a patch that I'm working on. \E. Silly. The Command E for edit. \E. The other slash. Yeah. There you go. All right. Where? All right. So this is. Yeah, we got to lose all those temp stuff. So just do select asterisk from MV.
I think I can just create tables that it was using.
Like it did. Okay, yeah, go ahead. Yeah.
Create table.
Is that all it had was a TID? Oh, you got to get rid of the PG temp _0 and change it to PG temp dot.
Like this?
Yeah, because that means your temporary thing, and I don't know. It might have been running on under Postmaster, which would be _0, right?
So and so here I
So
should
now every
change
place
it to...
here you have to change it to PG temp. Yeah, which is why I was kind of suggesting the editor mode. Then you can search and replace it, but that's fine. Oh, there's more. There's a full join on syntax.
Full join.
On. There you go. Boom, boom. Okay, so where's PG temp? PG temp.
Here is PG temp.
Yeah, so what was the syntax here? On PG temp.pg.
I mean, create how it was called.
Oh, yeah, that's fine. That should still be legit. It works. And it's got the same number, right? Is it the same number? No. Oh,
no,
they might have.
No.
They
it's
have,
they have many tables actually at once.
Ah.
So this ends with 2. And it's interesting because if we try to refresh now, probably it will fail because we created a table it needs to create. Yeah, we created a temporary table that interferes with.
That's funny.
Let's drop it. Drop table pg temp and create all the tables that we see here. This one. And what else?
Oh, you can leave the _0 if that's the one you own. Try doing that. Just try creating you can, you're probably fine because you started there's only one session running in the database, probably in Shu. So that's why it's #0. Just try real quick, do a create table on, oh, okay. Oh, look at that. They altered the table.
Yeah, they do it, but the order of logs doesn't seem to be
Yeah,
precisely
we might
correct.
not get everything. Yeah, but that's interesting. So this is how they did the materialized view concurrently. They just, well then, oh,
They
oh,
analyze tables that they created by some other means. This table, without 2, was not created by SQL.
uh-huh.
And let's see the code again.
Oh, temp table is always created, right? I just realized.
There are 2 temporary tables. One is created with SQL, and the other is created by, I don't understand how it is created. So this is analyze that we see. Here is make temp table n.
And it gives it a 2. Yeah.
Oh.
That's where the
So-
underscore.
so if-
It's just a name. It's name of the
creates a name.
table.
So if I run refresh message view every time I run it, there are temp table creation, and it suggests that we might have catalog bloat if we do it very, very often.
Probably
Wow.
so.
Yeah, just refresh. I just learned. Yeah, refresh message view can lead to catalog bloat. Of course, if it's extremely frequent. Yeah.
Warning. I want to add here a warning and say that this is the beginning of this function.
Would you
But-
consider 1,000 times an hour to be running it pretty often?
Asking for a friend, right, Kirk?
Yes, I'm asking for a friend who wants to be
well,
renamed anonymous.
it's not about just frequency, like how many per hour, but also how long your transactions are, because every time you have longer transaction and do many frequent catalog changes, vacuum cannot clean up the tuples in catalog, right? In catalog tables, right?
Yeah.
So if all your transactions are extremely fast, short living, so you should be fine. But if you have like 5 minutes transaction, and during which you refresh many times, well, vacuum cannot clean up those dead tuples during the transaction, and this is how bloat can be accumulated. Or, for example, you have not many workers, like default is only 3, and you have very like many active backends. This is also like another way to have bloat.
Our refresh on our materialized view takes about 1.4 seconds, so that's not a huge lock. Now that I understand how it works, it's like, okay, like I'm a little disappointed, to be honest.
Well, it's not one record in catalog view because of temporary table, a couple of them, right? It's just not a lot. Like you just avoid long running transactions, I would say, and make sure you have enough workers, or vacuum workers.
Yeah, and everything that calls this has the absolute slowest transaction that would call it using this would be about 6 seconds. So, So there's
Right. But do you have a long running like dump or select? Because every time you have it, it blocks auto vacuum for all tables, including catalog tables.
yeah. So because of this kind of stuff, and we had this problem with Oracle blowing up undo redo, we designed our system so that before we do things like backups and everything else, we pause all of our excessive stuff that, so that we don't generate that kind of nightmare. But yeah, we do that already. We take a pause on the things that do this stuff. We don't drop tables. We don't truncate tables even while a PG dump is running and stuff like that. So we have times where we, back off for that kind of stuff. So yeah, I'm not afraid of that. And we do that even when we have a nightly process that runs, and we back off during that process for this reason. Cool.
Yeah, what about indexes on catalog tables? Oh, I would check them for bloat.
Indexes on the PG tables
Yeah.
or on the, yeah. Well, I will tell you this. I see in the logs the PG tables are getting vacuumed. So I do see
Right.
that.
Right. But do you see the messages like for auto vacuum? It reports also like how many dead apples are found but cannot be deleted. This is the problem
Yeah,
that
you know
leads to
what? I
bloat.
will look in that. I will query the.
Yeah, because if there is long running something, X-Men Horizon, and we do a lot of refreshes. So yeah, but I think it's very rare to. Well, it's not very rare actually.
It
Okay,
can be
so
rare.
Yeah. Anyway,
small
this is off
part,
topic. Yeah.
small part of refresh materialized view concurrently is not SQL. So it is creating a copy of structural copy of materialized view, which will be used for storing transient data. And this is not defined with SQL. It's just defined as
Like a
Let's.
new.
it's in code.
Well,
Yes.
what I think this logically, view and materialized view particularly, it can be any query. It in simple case it's just one table, but it can be with where clause, right? In like it's some select statement with where clause, and if we want partial refresh, it's another where clause, another piece of where, and the problem will
Yes.
be in the end of the day, the problem will be how to combine two where clauses into one, right?
We can combine two where clauses with
Using
and clause.
yes, and
Yes.
keyword, yes, we can, yeah. This is right, and this will be correct, right?
Yeah, cursor is still offline, and
Oh,
I'm just starting to understand how difficult it to try ideas without it.
Yeah.
How did
I'm using
we?
my brain, and it's painful. I mean,
Ah,
I liked it a lot, but yet reading the
scroll up.
code online is now. I remember that session with about wall compression when I tried to read code online, and now I'm doing the same. I almost understand what is going on,
Yeah.
but
So
extended
let's
and
think further. Combining where it's not straightforward because for refresh, the where clause will be addressing materialized view itself with its column names and so on. But underlying tables in there where clause, they talk to underlying tables, like and with their column names and so on. And we need to translate materialized view level where clause to underlying table,
Actually,
right?
if
Before
you,
making end, right?
I think you can just add. Look, if you turned it into a sub-select on the materialized view with the additional where clause, okay, so make the entire materialized view a with query, and then just select from it with where only for our rows, copy our where clause. Then we get back only the rows we want to refresh or insert.
So
Here's the dilemma.
yeah.
If you scroll up a little bit, Andrey, I was reading the code, scroll up because this is doing a merge. right? Stop. That's the function. Refresh by match merge. This is interesting because if we could pass in a parameter here to say, hey, and we can cheat and produce a smaller set of data in the temp table, and then do the match merge, but tell it not to delete any rows in the existing one. Like, then we could actually do a merge update and leave all the rows there and only update the ones that have this column that changed, right? Or whatever we were changing. Because in the syntax, the other problem we have is if we say, well, it's going to bring back all of the columns anyways. So yeah, so it's just going to update row by row. But this is right here. You found the magic spot, right? There is a way to do a refresh by match merge. If we could do that by providing a flag that says, like, don't delete things out of the original, or only for these, do the match merge, but don't do any inserts or delete so that it actually just does an update, right? On those rows that have changed. Okay. That's where I'm
Kirk,
thinking. Go ahead.
Kirk, I think you are right that this is the place which would allow us to constrain how much roles are changed in a target view, but we also want to constrain how many
Can I
how
pull
many
you?
source data is read. Sorry.
Can you give
Yeah.
me a couple of minutes? Yeah.
Good.
So I see like two where clauses. One is, well, if you're forgetting about joins, possible joins, and so on, we see where at materialized view in refresh, which is we want to introduce, which should limit the scope of update work, refresh work, and we see underlying also like something, and we need to combine that. This is only in the case of a single table, but there can be a join involved. And in 2002, my bachelor degree thesis was updatable views. I remember I studied it. And at some point, Postgres also implemented it. Views, not materialized views, regular views. They support updates. And I think this reminds that problem quite closely, because we need to understand which tuples to touch. Sitting at view level, we need to go to, this is a term, underlying table, right, which is under the view. Here we also need to navigate which tuples to extract, basically. It's close. It's not the same, but it's quite close. It feels close. It's at theory level, not at practical level. Yeah, so maybe we should look at implementation of updatable views, maybe learn from there something. I don't know. I'm not sure. I just wanted a couple of minutes of attention. Thank you.
No,
What is updatable views?
You can create a view, and then you can update a view, and Postgres will automatically figure out how to update underlying tables according to.
So, but is materialized view updatable?
No, it's not at all. So,
but
here's why it doesn't do what we want, Nick. I hear you, and I understand. An updatable view gives you a way to say update view name, set column, and then you can always figure out where the column came from, right? And then apply the ID filter appropriately, right? You can construct that syntax and re-update the table. Easy enough. What's different with this version, okay, what we're talking about doing here is, now it would probably work if we said refresh a specific column on a view. Maybe we could pull that out, but what I think we're looking at doing here is we're providing the view ID of the entire row that needs to come back. So the view technically to do the update or refresh for that row in a materialized view must go get effectively the current value. It must execute the core query with the where filter for a single ID, okay, against all the original tables. And that's what it has to come back with for the current data. And then what we're talking about is now, once we have that limited set, merging that into the view. The challenge is the current merge logic, right? The current merge logic is broken because what it does is if I only gave it 4 rows in my new materialized view, it would delete everything else but those 4 rows. That's how this function works.
So yes, so Andrey just tested if you have aggregate, updatability of view is broken and it's not supported. Because only simple cases are supported, obviously. In our case, we need to support all everything, even if it's like some aggregate function is involved. We need to traverse like and find which tuples to involve and execute it's an interesting problem actually. Maybe it will have its own challenges compared to updatable
So
views.
my breakdown on it was do the select, applying against the
Additional filter.
additional view. Right. Start with the raw view, apply the additional filter, get those rows, and then call that routine that was highlighted on the screen and tell that one, hey, only merge in the changes from rows that match. Okay.
Yeah, sounds
Ignore
like doable.
Inserts and deletes. Right. Ignore inserts and deletes. Just merge in this data for the data that matched. I think
sounds like simpler problem. Yeah. Theoretically, right? Not practically.
Right. Well. Listen. There's things that are simpler than climbing Mount Everest. Clearly, they're still really hard. So, but here. So, did you get my overall, Andrey? Did you get my question there? Would there be a way that we could modify this routine to tell it to effectively do the merge only when it matches the rows in both tables, the original data with the new data? And only if it has a match, like basically it can either do an insert or an update. It cannot do a delete. Okay, is basically what I'm saying. And then this way we can give it a subset of the original view. Okay, maybe it's one row. One row is the simplest one to understand. And then what it does is it doesn't do any deletes, but it finds that one row and then it applies this merge logic to it. And then it finishes, it exits. So all we're doing is turning off the delete feature while we're applying this. Like that's the simplest hack I can think of. Okay, is when it's in this mode, it's turning off the delete from the.
There is only this delete. Let me double check. There is only one delete in this file, and this is where the deletion is going on.
Yep.
And here we are taking everything from div table.
So I wonder, so do you think this is actually deleting everything that's different and then reinserting everything that's different? That's how it looks like it's doing it. Look at
Yes,
that.
I think so. That's what's going on here. So delete every row that change it. So this div table have columns view data, and if in a new result it's not existent, we delete it from our materialized view.
Right.
If it's not null, we insert new version. And we are not doing updates, by the way, here.
Wow.
We're doing here only inserts and deletes.
Love it. Now you need to, you may have just simplified this problem. Like for a limited solution with a plugin or with an extension, this can work. Please tell me how they can modify this table, but my syntax is not allowed to. How is this happening?
I didn't get the question, sorry.
Remember, if you attempt to insert into a materialized view, it says no, right? If you delete from a materialized view, it says no. It blocks it specifically because it's part of the normal construct. Is this working on the actual materialized view or the temp table that it copies back to the materialized view?
Let's use the error and try to find where it's generated. cannot change materialized view. You can copy this literal and find it out.
Perfect.
And we can comment it out. We need not just comment it out, we need to replace it with the
Something
code
for a
for
table.
regular relation. Yeah.
So these two.
This ought to be enough. I hope. Let's compile.
Oh, that is
And
crazy.
that's interesting. How do they override? Because it was in a very different file.
Right. Unless, of course, what they're doing is they're doing all of those commands on the temp tables. Okay.
Yeah,
And then
so
once the temp tables are good, oh, it works now.
uh-huh.
Oh, do update materialized view. Try this. Update MV. Okay. Set. What is it? Column A equals okay, A+1, that's fine. Where A equals 3. Just set it to 3 or well, okay. Oh, because you don't have to actually hit a row. That's fine. Oh, there you go. Oh my God. Okay, that now select from the materialized view though, because none of those numbers should have been negative. So the first one probably didn't. Yeah. Look at that.
Yeah.
Oh, do -11. Go back up and do -12 to -11. Your
I didn't get it.
update. Yeah. Yeah, that was it. Down from where you were. When it says where, yeah, change that 12 to 11. There you go. And now it'll set it to -3 is fine, or -12. There you go. And then where A is less than, yeah, or less than 0, but now you have it. Okay.
Yeah.
Interesting. Interesting.
But
how does it do it though? And I think it's just doing the temp table.
It is
because
actually
this name, map view, and no, it says map view.
yes. I think that SPI exec is going
around
like
this.
on another road. So when we are doing this SPI exec, it just bypasses this check valid result rel.
Okay, I'm going to put a dollar amount inside the Telegram private chat for you. If we can create a extension that basically lets us execute the update on a materialized view row in a specific column kind of thing, I'll pay you that $sign for that. Wow.
So that's very.
Meanwhile, our group already has 10 members.
Oh,
and
we are popular.
Yeah.
That's cool.
And I created a short link t.me/postgres_hacking. Not very short, but easy to share and so on.
Works.
Yeah.
Oh,
I'm not sure about goals. Yeah, let's discuss later.
Michael joined.
Yeah, Michael joined. Hello, Michael. If you're watching us, yeah.
So.
Oh, that is
this.
Dude, that's crazy. Because that's all we really need is the ability to call that execute command and execute it. I mean, in all honesty, if it can be an extension, like consider
extensions that bypasses. Of course, you can create an extension that is calling SPI exec. That's
right.
not a big deal. Maybe there is some extendable way to avoid
extension.
Oh yeah, maybe.
Result.
I don't like extensions because we have so
many.
Yeah,
it makes it hard in other places. And it's long term, it's the wrong way. But wow. So I wonder what makes this so special. Oh, here's one for you. Select from the index and make sure the index updated for that value of I. It makes me wonder. if the
I think
value.
this is going through index. Huh.
Uh-huh. Oh, the minus. What did we set it to though? We set it
It's
to,
an index scanner that it finds
and it
error.
found it.
So
Oh,
it
that
it
is
is just a regular relation without any like differences. It just works. And the thing is, like we are guarded by this function, check what it result relation, and it's clearly a variable from extension.
yeah, interesting. Okay, this is, dude, the fact that so far what we learned is a couple things. First, we learned that, oh, we can execute code against this table and actually do what we want, and it looks like it works properly. Okay. Can you check the CT IDs on those rows that got updated? I'm assuming it all works because this is the internal stuff that's used, right?
Yeah.
There you go. And then select it from something else too. So that's 5 and 6, and then yeah, here we go.
So something that was generated at the
Yeah,
beginning
yeah,
and something that we added later.
beautiful, beautiful. That's what I'm expecting to see. So since that exists, so now your question is there another way we could try to get this update through? Okay. Um, without throwing the air, okay, which it's going to do, like it's kind of built in without having an extension. The fact that we can have an extension that we create that effectively all it does is call a simple DTI execute, okay. Wow, that's easy speasy, kind of thing. um that would be interesting. As long as we didn't have to worry about memory leaks or anything else, right? Obviously, it's got to be pounded through some tests, but that's interesting. I
I
like
think
it.
as far as transaction finishes, like transaction context is invalidated and there can't be any memory leaks. This is just a table and you
Yeah.
can do some. It's just
The other way to do it
syntax.
would be to turn on a guck, create a guck, which I know they hate, but create a guck that allows you, and then it puts a condition on this block that it had before.
like this. Let me restore the error and just just comment out node modify table. Uh, yeah. Well, the way anything to bypass this check effectively can allow the user to make database into inconsistent state. So I'm not sure that it's
Oh,
it's safe.
right. Right. Well, this would be the case. That's why I would rather code it on the, if it's a materialized view and the guck is set, then say it's okay to do. Like, but let's back
So
up the question. Does this mean that they're not logging table changes into the wall for this materialized view
no,
update? No. Good.
no, it's just a couple of SQL queries. And materialized view is basically a syntax sugar
Yeah.
for
For a table.
running the SQL queries. Yes, you can create a table that is filled with mm, w- with some SQL, and you can refill it again with another SQL. It's just a way to write less queries by hand. But under the hood, there are still a lot of SQL queries, and seems like there's nothing else.
Yeah. Yeah. I mean, honestly, it's crazy. I mean, look, it makes sense. They did it in a simple, straightforward process. Okay. Which I'm kind of liking right now. Like I kind of like what they did here. Okay. Um, the thing is that because I see how straightforward this is, it is an actual table. Okay.
Mm-hmm.
That's right. It's an actual table, even though it's a materialized view, it's an actual table. So now the question becomes, oh, right, what do we do, okay, with this? How can we do what we want to do? And it looks like it's not far away from being able to insert or update into it if we wanted to. What would be the
Mm-hmm.
argument to not allow us to do that if we turned it on? Even and if we said, hey, look, this is dangerous, you can't trust the data in this table. Okay. Because in our world, we're still going to refresh it every hour. We're just tired of
If
refreshing it, 1,000 times an hour.
if we are refreshing with somewhere close, does it involve less computations on select?
Well, and for my use case, which is specific, it's always only one column and one ID. Like we're only updating one row with one column value. Okay. That's all we're doing. But we have to refresh. I forget how many columns it is. I can count them, but we have to refresh a ton. And that's the part that makes it expensive. And it's expensive across all the tables. It's not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, about 18 columns. So, and we only need to update one. And instead, we're updating 4,000 rows times 18 columns.
Mm-hmm. That's a lot.
Yeah, it's just inefficient. So
Yes.
so
I
if I
think
had a way, how would you do it? Talk to me.
I think we need to get back cursor to working state and try to implement it. I mean, I probably I could add this to grammar myself, but it would require a few hours of basically bringing bytes
Dedicated.
from abstract syntax tree to this place and adding where close everywhere here. Probably we will have something like and here, and then append string. No, not and, maybe something like append string with and something
Here's what
else,
you could do. Yeah, hold on. And then I would just say whatever the IDs are in, and I would leave it at that. Like some
like
underscore IDs in.
%s, and here is a user qual.
There you go, something like that.
Yeah. Could we just transfer this knowledge to a prompt to cursor somehow? Okay.
This is the problem when you use an integrated one as opposed to the right, because you get used to the level of integration. And I'm going to double check cursor right now just to see if they're still having a tough time. Oh, hold on. They might be fixed. Try to connect. It logged me in, it looks like. Okay, let's see if cursor thing realizes I'm logged in.
It's still down for me.
Okay.
Okay, so maybe let's wrap up for today.
This is my favorite part. Yeah. Something worked, something didn't work enough for
Something,
today.
something old, something new.
We don't have managers who say tomorrow is release, right?
Oh gosh. Yeah, thankfully.
So, like a lot of unfinished work is fine. Yeah.
So, well, high level summary though, we looked at how to come into a materialized view and we didn't know how they work to do refresh concurrently. We found the code that does it, and we're all kind of shocked that it actually uses pure SQL to do this stuff. It creates a temp table, it calculates some diffs, and then it merges in those changes by inserting or by deleting the rows and reinserting the new ones. It looks like it uses the syntax of multiple field values inside of a inside parentheses. I forgot the record structure. So they use a column as a record that contains the data. And then they pay a particular attention if that is a null value, meaning there was no record value from the other select side. So they grab every version of the row. It looks like they put them in a single table, temp table, where they have the old version and the new version. And then effectively what they're doing, and this is genius, we're learning some stuff here. So the learning is amazing. We learned that you can actually do that and diff that, and then delete the ones that are going to come out where there's no match in the new data. Makes sense. This is a normal refresh version. And then you go ahead and insert back in everything that's basically new. Okay. And it looks for that down by line 885. It's inserting into there so it's selecting the diff.new data asterisk. So it's re-expanding that column into the data. And it's saying where TID is null. And that means where there was no current value. So it's inserting new records by using that statement. So the fundamental, now should be putting all of this, my understanding is this was doing this into the temp tables, but I don't think it is. I think it's actually because it uses mat view name in the append to string. So, and then the XPI exec executes it. So it's actually using the material view's name as a table. So it doesn't look like it's wiping and blowing it away. It's generating the smallest set of inserts and updates it can do for the rows that have changed. This makes it pretty efficient, right? And then it only deletes the ones it needs to, inserts the ones that are remaining, and then it effectively commits those changes. And since it used normal inserts and deletes, it was fine. Interesting. And if we were to just tweak this code to basically process changes, to limit the changes, the key thing we would do is we'd get rid of the delete. Okay. So if we queried for a bunch of IDs that didn't exist, our flag would have to tell it somehow, and that's the qual, which rows we're actually doing this for. And we'd have to build the temp table with only those rows technically. Okay. And then we'd have to say, don't do any deletes and just insert any new records and update the rest. But that begs the question. I thought you said there were no updates. Am I not understanding something?
We can do updates, but currently this function do not do updates. It just don't need it.
It's only doing inserts and deletes. That means it
Yes.
deletes, hold on, that means it should delete everything first.
No.
Okay, then it's deleting the stuff that no longer matches.
It's
Search for the
deleting the
delete.
stuff that is not present in new version, and also deleting the stuff that changed, that will be reinserted into the materialized view.
Oh, so it is deleting from the materialized view where the operator equals any, CTID equals any. Okay, interesting. Subs and it's any of the ones it selects from below. So that's from the difference table. Okay. So now it's selecting the TIDs from the difference table, where the diff TID is not null and the new data is null. So it knows it has, okay, so when it created the diff table, that's when it figured out how to do the updates. That's when it figured out what needed to be changed. Okay, got it. All right, so anyways, so it does all of this using SQL, which blew my mind. But also I knew that the SQL syntax for inserting into a materialized view didn't work. Andrey verified it. It doesn't work. And therefore we had to figure out why. And it's because SPI underscore exec function when called does not actually do that validation step. So it doesn't hit the piece that says you're not allowed to do this. So it actually does allow inserts, deletes, and even updates, as we found out, if that feature is disabled. So if we were either call SPI exec or disable that feature, interesting, then we could get this to work. Nice.
Maybe we will be able to make mat views updatable.
Yeah, I'll be honest.
Ooh.
Since it's using normal SQL,
It will remind us ClickHouse, right? Because their definition of mat view is completely different from ours, from normal people mat view definition. I mean, normal relational databases. Like they write to mat views all the time, right?
yeah. So
Oh, we can allow it, but in
Maybe we
our hacked
will.
version.
Maybe
Do we
one day
have
we will
strong
be able.
arguments for this?
One day, different storage engine could be used for mat views. For example, column store, and you write to it, but it will propagate to row store. I don't know. It's just some crazy ideas pop up in my head. Just some crazy
it's
ideas.
just a table. You can use that heap
Yeah.
for a table. Why not?
And there is already updatable views. If in simple cases, you try difficult case with aggregated thing, but in simple cases it
Yeah.
works. Yeah. So
Yeah,
I
I
don't know.
tried
It's just
and
idea.
it works. So we already can update materialized views, but it won't propagate to
Underlying
relation
tables.
Yeah. Yes.
Yeah.
Oh,
Okay,
what
anyway.
happened there? It won't propagate to the underlying table. Oh yeah, no, that we don't want that. Right. Because typically
We
what's
might want
happening,
it, but it's a different task, different idea.
right. And in fact, what I was looking for here was to limit the number of rows on the way into this routine to force it to do it only for some of the rows, right? Some ID range. So execute the base query for the ID range, and then, right, execute the base query of the materialized view for a specific range of ID, and then call a version of this that has an extra parameter that basically doesn't let it delete anything. Okay, right? Unless it was deleted, you don't know that if it's deleted. So this would only apply updates and inserts the way I was visualizing it.
On
Not
the
delete.
other hand, updatable views don't work for views over two tables with join, right? Then it's not supported, right? Or is it supported?
I think it can. I think it's supported as long as it's clear, as long as they can make out where the column comes from, because they have. I mean, that's the one thing they know, right? Each column comes from a specific table. So as long as you dereferenced it.
Okay.
Oh no! If the column's in both tables, it creates a problem.
Okay, it's just a separate topic.
Yeah.
Off topic.
Anyways, this was interesting. I'm excited.
Good.
There's some future ideas that come out of this. A good topic. Welcome back, guys.
Yeah.
Yeah, that was funny. Thank you, guys.
Yeah. See you soon, I hope. Bye bye.
Yeah.